So I promise to do everything on stream here, so sorry, I need to get my music in order. Personal music. Okay. Go to determine whether or not my position is illegal or not. And before I was wrong, I also have to check if the pieces are on the same square. Normally, I have the tendency to do micro optimizations, think a very long time about how I can write code that is a few nanoseconds faster and stuff. And in this case, I think I'm just gonna code it that it works. I don't care about if it is fast or not. Okay, well, let's make some ASCII art. Yeah, illegal is really the point, right? Where's my cursor? I think I pressed caps lock or... Oh, fuck. Seriously. Undo. 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 Yep, I think I pressed caps lock. I don't know. I'm not English. Is it file enough, or do I have to split it up in row and column, or file and column, or file and row? I don't know. I just should say row and leave it at it. So let's say dx is the distance, the horizontal. No, we work with n and m, although, well, horizontal is n. I'll just use dx. Could say dn, but nah. I don't know. So I'll make it an absolute value. So we need the position of the king x coordinates, or n coordinate rather. Let's say the black king. BK here is we are inside the iterator, the board iterator. So we have BK, well, black king, white rook, and all of them are iterators. A king iterator has a pos and color, and the rook iterator only has pos. So it's pos and color, and then of course the color itself. Well, that is oh, that's to play. Okay, and that's a color type. It's not even a color. Yeah, whatever. I don't know. Yeah, probably not very good too. I should probably use color. I mean, a color is this structure, not that, you know. Yeah, I'll just use color here. And then I don't need this anymore. You can just use to play, call to play, which is public anyway. But I do probably need I don't know, something. Assignment is one thing. Can I just assign that? No. I can construct it from a color type, so probably also should be able to assign it. Just make an assignment operator. Well, those return references, right? So we're going to assign from color type. I want that to be possible. Might as well do that in line because it's a super short function. Crying out loud, I really have to fix this. Filters incomplete type color because there's no closing brace. Seriously? I don't see it. Totally looks like a correct clause. So field is incomplete type color. The node definition of color is not complete until we are not outside of the clause yet. I read it as a missing closing parenthesis. Yeah, okay, I get it. Yeah, in that case, so since this is a nested class or well struct, same thing, inside color, you cannot use color inside of it. Which then means that maybe I should change it back because yeah, I still can't do that. Arg. Or I can move it outside, of course, but then we don't have color either. The whole thing doesn't depend on iterator though. Yeah, nah. Yeah, okay, whatever. I use a color type here then. Might still keep this one though. Can still keep this one, as I didn't even have to do anything with the iterator. Okay, still, that one did work though. So why can I use this and not the other one? It's very strange. Is that like incomplete as well? Apparently not incomplete enough. Colors should be marked as const. Hi, Jim. So you're chess good enough to know how to move a king? How does the king move in chess? That's the only thing you need to know. Well, and the rook, but it's almost simple, right? I mean, even simpler, more or less. Absolute value of, okay, so BK is an iterator. Let's jump to it. So king, black king, iterator, this thing. And then you have pos, that it would be the position, but it's iterator, position iterator, which in turn has just a sum and an M. This star is annoying because it's not what I did in the other cases. I just name them like that. And then of course it doesn't compile anymore. I think. Start it again. I'm not sure if I'm happy with this, though. There's pos position. It's like, okay, I abbreviated pos, but now it's position dot position. That's really weird. The naming is not correct. I should improve the naming of the functions and all variables, I think. There was a question to you, yes. It was to you. It said, hi AG, do you know how the king moves? Maybe it helps a little bit if I use a different name for these. I mean, I'm using a lowercase k already, but it still reads like Black King. And I want to make it a little bit more clear that it is an iterator, although it's not a real iterator. It's just my iterator class. But still. So let's say I do grab sources for blacking with a lowercase k, that you give me all the places where this iterator is used. Here's defined, and then here it is used. So let's call them. Sometimes the editor is really hard to use. So this is an iterator, and therefore I'm going to add an I there. Yes. Or shall I not use abbreviations? I'm calling it iter. So there. Now it's clear. If you see something like this, you really want to do just use an arrow here, right? This is what you really want to type. Iterator, pointer, that's would be dereference and access. But operator arrow must return a pointer, and then I don't have an instance that I can use to point to unless we also put that in the iterator. It is probably not that much of a problem. Use a little bit more memory for iterators. Iterators are stored where I think I hardly even use them. Might as well do this. I mean, I don't know. It's using more memory just for syntax. The point is, okay, if you have a normal iterator, like an iterator type defined in a standard C++ container, and a variable is called iter, then you can either dereference it, and then you get a pointer to the class that it was pointing to, and if that is the king, then you can get the position of that. Or you can dereference it, which then becomes a reference to the king, on which you can call pos. But in this case, my iterator is not really pointing to an existing king, it just represents a king. So I don't have a pointer to it. I can create it, but that then is a temporary king that I created from the internal variables of my iterator. So this would work where then the operator star is no longer returning a reference, but it's just returning the king by value. But this cannot work because we don't have a king, so I can not have a king pointer. I do have this. So the iterators could point to these things. But then you need a board. So I could say I have a board which represents a position, and then the iterator is created from that board. And then incrementing the iterator means that you go to the next position, starting from that board. Then the board is my container, between quotes, and the iterator, well, normally, no, it still doesn't work. I mean, you really want to be able to dereference an iterator, of course, without needing access to. It's kind of weird, though. Well, I would have the iterator would need an internal board pointer then. I don't think a normal iterator has a pointer to its container, however. Pretty sure it doesn't. I think the only way to do this is by replacing the variables that I have inside the iterator with the variables inside what they point to. So currently, well, this iterator is defined in terms of a color and an position iterator. And so that's too difficult. Let's just go to the position. And then the position iterator is defined in terms of a sum and m, but we could have it simply point to a position and then let the position itself represent these variables. If you understand what I mean. Let's just do that, because it just, then become much closer to what an iterator really is. And we can even do it in parts. So let's say go back to where I was editing. Like this, so this compiles and it runs, as in does something. I'm not printing anything. In a minute, let's print something then. Okay, so this is moving the rook over the diagonals like this to this corner, and then it does the same thing with the white king. So the white king moves over the diagonal, and then this diagonal, and then that diagonal, and so on. And when the king gets to the end, it moves the black king over these diagonals. So it's taking forever if you print it. But this is enough to check that it works. And now we're going to rewrite the iterator position and as follows. 1, I need these variables to correspond to an actual position. So we can no longer have sum, we must have n. So we're going to rename sum to n. And then, of course, everywhere where we have sum, we must use, what it represented. That was n plus m. So this becomes n plus m minus m. Yeah, that's just n. And then it should only be used in this file here. Let's just remove the underscore. Okay, so the sum is n plus m. And here as well. And here, this if m becomes 0 and the sum is 0, then n is 0. So just set n and m both to 0. Which then leaves only the increment here. Yeah, so sum was replaced with n. So what I really need to do here is set the value of n to the sum that we just calculated, minus m. But you don't have this sum. However, I can temporarily calculate it. Because before I increment it, sum is equal to n plus m. But I already changed m. Wait a minute. No, I did not change m. We come here, we do something, but if incremented m, then I would have returned true. So at the moment that we enter this function, sum equals n plus m. And then we increment sum. And then I use the old sum, no, the new sum. And then we know what the n is, because that's what it replaces. Feels to me that maybe someone watching this thinks it's super trivial, but I'm not seeing it. Okay, so we don't really need sum, of course. But this sum is that sum plus 1. So let's put 1 here. Get rid of that. You see, it's just an increment of n. Yeah, of course it is. So we traverse over the constant sum lines. Those diagonals here, look like this one or this one. And we get here every time we reach the end with m. So that means that n is that we go all the way till here, and then we continue there, and then follow this line, and then we go there and we follow this line, and that jump has a certain value of n where m equals 0, at least in the beginning. Here it's not, though. But n itself, I mean, we skip this part here. But if we would not have this limit here, then n just increments, yeah, every time. So we do this, and then n gets larger because we do this one and this one and this one and this one. Okay, suddenly it makes sense. It's just plus n. And then I guess I do not really have to do this difficult here. We immediately know that we reach the end now, because if n at the moment n becomes equal to the horizontal limit, then we have to stop. See if that's still the same thing. So is after this increment n becomes equal to board horizontal limit, and then n equals horizontal limit, and we subtract that, so that drops out. And I do a minus 1. So m becomes the maximum of m plus 1, which means that we just increment m until m is no longer, well, as long as it is less than the vertical limit, then that's okay, and otherwise we stop. Yeah. So the 0 here is the starting value of m while we follow this line. And then that part is the value of m while we follow this vertical line down, which then corresponds to the end value that you find if you go, let's say we are here and we follow this vertical line, the diagonal line here to there. That is the end value. And this is then the m value. So when the m value reaches vertical limit, then we are at the end. Oh, as you see, that's not true what I said. Because this point here corresponds to this end value, which is way beyond the limit. So you really have to test it like that. Yep, but yeah, this way it should work. And then there is only one n there, so I might as well increment here. Yeah, it's not a very clear quad duck, very clear picture this. And my mouse is also not a good pointer in this text edit. But, well, it's not super important. We just, I can tell you though what it's doing with a nicer picture. We had it here. So we have these 3 pieces, and each piece moves like this. We starts in this corner, and then there, and then there, and then here, 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 and then there, and then this diagonal, and then this diagonal, and then this diagonal, and so further. But there is a vertical limit here. We cannot go below this point, and we cannot go to the right of this horizontal limit. This edge does not really exist, but you know, you have to limit it somewhere, because otherwise it takes an infinite time to compute. So we make this, do this diagonal, and then this diagonal, and then this diagonal, and then something special happens when we hit this limit here. Then we don't start here and then follow this diagonal, we immediately start here. So then we follow this diagonal and then this diagonal and so on until we are there. It's just diagonally filling this whole rectangle here. That's what the algorithm is doing. So now our position iterator has no longer the sum of n plus m as variable, but just n. And it should still be doing the same thing. And we can test that, of course, by, well, that's the only thing I changed, but let's test it. And it's totally not doing the same thing. I have made a mistake, yeah, clearly. You see, the rook is now not following diagonals, it's going up straight down. Yeah, that makes sense, I understand why. Oops, I should go here, maybe? Yeah. Before the sum was an invariant, so if I increment m, then the sum did not change, which means that we have to decrement n here in order to get the same effect. So m is incremented, but the sum of m plus n is kept constant. While this part was only changing the sum. I think that's still correct. We can just test it out. Nope, still not working. It's following this diagonal now and then repeats the same diagonal over and over and over. So we don't go to the next diagonal. Why is that? Oh yeah, of course. I'm incrementing n because I was thinking that n didn't change and then we have to increment it. But in the meantime, we have decremented n. So this is not how it works. N must be set such that we reach the next sum. So n must be set to the value. Now I'm going to do it like this again, because it was not that trivial again, apparently. N must be set to the next sum. Minus, well, wait a minute, I don't know what m is. Well, I meant plus. Without knowing what m is, I don't know what the sum is. What the hell? Yep, let's do it like this. Let's make an intermediate sum. So I deleted the sum, which is very annoying. I just need the sum. So I'm adding it again. And then here the sum must be incremented. So I might as well add plus 1 then. Okay. Let's increment the sum. And then this was just a sum. So then with that we can calculate the starting value of m. And now we have m. So now we can calculate n. That looks much better. I'm just looking at the white king, which moves way slower. So now the white king should go there. Yep, and then there. And then I believe it. Well, it goes here. Okay, I think that now we have it. And then the next step is that we replace these two variables, which are now not sum and m, but n and m. So therefore, I can replace it with a position. except that I can't because position is not complete yet. Meaning that we really have to move this iterator outside of this class. How annoying is that? Should put it down there. You could even put it in its own header file maybe, but nah. Yes, so instead of N and M, we now have a position. And it's going to have to be a position pointer that we can change. So, or a reference, doesn't really matter. Shall I make it a reference? Yeah, I don't need to change it later on. So the underlying position, I'll just keep abbreviation for now, is like that. And then, of course, if I want to get an access to that, I might as well I just return the reference instead of by value. And I need a constructor now because we need to initialize this reference. So my position iterator has to be constructed from a position reference. And then two things changed. Three things changed. The iterators moved outside of the position class and renamed to something else. Secondly, the constructor is changed. It's no longer a default constructor, but we must pass a reference to some position. And thirdly, it no longer has N and M, but it now has pos. But I think the compiler is going to complain about all three cases, and I'm just going to fix all the compile errors. So the first one is no type named iterator in position. Yep, okay. So I'm going to rename this one to position iterator. And then might as well grab the source for every occurrence of that. Okay, that was the rename. Make. Combination between make and next is max, apparently. Use of undeclared identifier N, yeah, because we don't have that anymore. We now have pos. So the iterator has pos, and then that is a position. Position is a struct, so we can just access it, N and M of the pos. Wait a minute, pos was a reference. So we have pos reference.m pos.n pos.n pos.m pos.m That's position, nothing to do with the iterator. Must be underscore, pos underscore. And I forgot one. Call to implicitly deleted default constructor. So that's a third thing. It doesn't have a default constructor anymore. We have to pass a reference to something, to a position. I guess it's the starting position. Okay, so position start, or well, it's going to be changed. I'm gonna need a lot of positions though, so basically I just need a whole board. That is the starting board then, but okay. So we start with a default constructed board, and then the board iterator is constructed from that board. And that should take care of the constructor. That is, my iterator now is constructed from a board. Wait a minute, this is nonsense. What am I doing? Yeah, we have a constructor, sorry. The iterator is constructed from a board. It's the begin board, basically. Can call this begin, I suppose. And then I have to pass stuff to. It's not that easy. Well, in the end, we want to end up with passing a reference to begin dot black king here, and the white king must be initialized from a reference to the white king. Well, actually not an iterator, but yeah, the real king. The to play iterator begin dot. Okay, let's see. The board has, of course, who is to play. And this to play. And the white rook iterator is then constructed from begin dot the white rook. This change is too big. I have to. I don't think this will work until all the iterators are moved outside of their class and renamed and stuff. So I did the position. I still have to do the king and the rook and the collar. So it's 3 more. Might as well just start with it, if you get what I mean. So I'm going to make big changes in king and rook and color. Meaning that we move it, the iterator, outside of the class. And I rename it to king iterator. And we need a constructor. Constructor that takes a king reference, which is called king. And then the position iterator takes a position, I guess, begin dot pos. And the color can be just constructed from by value, from begin dot to play. And do the same thing here. Well, this is a color type, and we get a color. So, what is that? That's just color underscore. And then compile errors to the rescue. Pos is a private member. Declare private here. Yeah, rook is a class, okay, but we do have an const reference to the position, which I could use, but we really need a non-const reference, and I don't want to add an accessor that gives non-const access. So rather, we just need to make this struct a friend, so it has access to the rook. I'm going to for declare it here, and then define it as a friend, which I put in front of this variable, so we know that the friend needs access to the pos. And then, yeah, of course, we need the same thing for the king, right? It's going to be... So we have a friend struct king iterator, which needs access. No member named to play in king. Oh. Now king has a color. Just color of the king. Just we're abusing this color now. Really, it's in this case it's the two-play color. Well, since this is a king, I just use color instead. No tab name iterator in king. Yeah, I moved it. We moved it outside of the class. So this is now a king iterator. And this is a rook iterator. And then this is the color iterator. Just renamed all three of them. Yeah, we have to we probably have a lot of those, so let's find them. Iterator. Just an accessor. And not, well, now we can just return the reference, I think. So let's make that one inline. I don't do any of this. Yeah. So instead of this, I have this thing, and I'm going to return a const reference instead of by value. Oh, wait a minute. Not yet, actually, because I still didn't change that. So it must still be by value for the moment. Okay. Thought it would be a lot, but nothing, just one, just a king iterator. Oh, it compiles. Yeah, that works. Okay. That's good. Now we do the same thing here. Instead of storing pos and color, I'm going to just have a king reference. Then no longer have that, and then this becomes just king begin. And therefore now pos is just the mem of king. So this is king, and we have pos and color. Before we had pos and color here, but now we have a reference to a king object that stores those things. So instead of pos, we just use king pos. And the same thing for the color. I think that's it, right? There may be something here. No. Just use an accessor, so nothing changed there. Something went wrong. No member named next in position. Oh, wait a minute. I need a post that is an iterator. Help. I wish I could go back to what to see again what I had here. I think we had a color and a position iterator, yeah. And the position iterator by itself is a reference. Seems that I need to add a member here, but it's a bit confusing. Why would that need? I would expect all the iterators to be as large as one reference. So what am I missing? Why would I need a position iterator here? Second reference. Okay. Mm. No, I don't know. It's just called core. Good. So now my iterators are much more like an iterator. And I can indeed just use an arrow here, which just looks better. It's the only reason that we did this, basically. Okay, board to play iter is a color iterator, which is also a real iterator, I think. Yes. I have a color accessor. Is that not the only thing I need? It's the only thing I need. But a bit weird. I mean, totally weird. So we're going to remove this and replace this with arrow operator. And then we can, we finally can do that at all. Because now we have something that you can actually point to, namely the object that this reference is pointing to. But yeah, in this case, I don't need a member of color, I just need color itself. So more logical would be to just get a dereference of it, so that we need that operator rather. And I called all of them iter, so let's see, So I could now even replace next with plus, but it's not really returning what you would expect then. So let's keep it at next. And then all my iterators need to do the same thing. We don't use this anymore, we just use operator arrow, which must return a pointer, and then yeah, pointer, or the pointer to king. And the same thing with the rook. And the color, I just dereference it because, well, there is not really anything to access, but well, normally maybe we need that one as well. So we're gonna return a color reference for operator star, the dereference operator. But might as well keep the operator arrow as well. No, and so on. And then finally back to the illegal. So what I needed here was access to whatever this iterator points to, because we are inside the board iterator. And the board iterator, it is not still inside the board, defined inside the board. No, yeah, why not? So the board iterator has a BK iterator, which is It's no longer bk, it's bk iterator. And I need the x coordinate, which I call n. So we want that to be, you know, I want that I can type this. Does that make sense? What I do get back from the arrow operator of the black king ether is a king reference, and that is a class. So yeah, board is not a friend of king, so we can just we have to call an accessor. Do we not already have an accessor for n? Oh, wait a minute, I don't have that, of course. We only have position. We have an accessor for position. I could, of course, add an n here, which then calls something on pos. Let's do it in 2 steps, maybe. Let's do it in 2 steps. So we have the black king position. A reference to is iterator pos, using the accessor of the king object, which, and we get a king pointer from this dereference. And then having the black king pos, you have well, that is a position, and that then is a struct, so now I can access n directly. And the white king pos, what the hell? There's a bit of problem of this keyboard, I think. If I let go of the shift key and then type the next character, next key, many times it thinks that the shift is still pressed. Just a tiny little bit too slow with releasing the shift key. That's why things often go wrong, you know, with this stupid keyboard. Let's see, the white king position is the white king iterator, dereferenced accessing the position of that king. And then we have this thing .n, and then the same thing but with m. No, this nonsense. dy. Okay, I think this goes like if as long as it is illegal, we just do a loop. So I don't even need illegal. And as soon as it is not legal, then we just break out of this loop. So I'm gonna do blah blah blah. If it is illegal, continue, and then if we ever get to the end, then it was not illegal. Okay, so this is test number 1. If dx is less than or equal 1 and dy is less than or equal 1, then the kings are next to each other or on top of each other. which means that it is illegal, so then we do continue. We start at the top again. Could go to the next position. Get the position of the rook. If the white rook position equals the black king position, or the white rook position equals the white king position, then it is illegal. Let's see if we have this equal. I think I can already compare positions, right? So it should just compile. Yep. And now it is also illegal if white is to move. This is too complex. Let's split it up a bit. Might as well do the other test. No, well, yeah, I can do that if we put the next thing here and the comment fits there. Same thing here. I guess, well, nah, whatever. I'm just gonna call it, is it file or, I think it's file, right? Yeah, of course it's file, certainly in chess. And then what we are going to test here is, so this test if is white to move. And here I get, and the white king is not in the middle. Same thing here. So not in the middle. If not in the middle, then black is in check. Well, white is to move, so that's illegal. So then I have to do continue. And there as well. So on the dot 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 we have to check if the white king is in between the rook and the other king for the n coordinate. How do you do that? Test if some variable is in between two other variables. I think I'm just going to do two compares. So it must be, yeah, in between. So, but it's slightly more difficult because I don't know which one is smaller. Okay, the lazy way, right? And the not fast but the readable way. So we need the minimum of the stuff that is involved, being the black king position n coordinate and the white rook position n coordinate. Must be less than or equal, but that's not true because we already left here. The white king position in so this is true if it is in the middle, and we need a not, so I need to negate this thing. But I like to write it like that. So this is some magic by itself, and that means that this variable is now in between that value and that value. Otherwise, it's less readable, so I'm just going to do not, add another parenthesis around everything. This should skip all illegal positions, which is super interesting, I think. I want to see that happen. How about we make the sleep a lot longer? So you can look at it. Longer, like a second. Yeah. Okay, so this is black to play, therefore we also have the mate positions. But that, of course, is mate then, but that's not an illegal position, that's just mate. So now we get, oh, the kings are next to each other, so stop it, because this is not correct. How did it not detect it? It even starts with everything at the same place. But maybe that's because I should not start at this position, of course. Yeah, I want this. I want to see that this is skipped, and then maybe we should change the default constructor from this to the first position. It's a first legal position. Yeah, why is it? This is second position. I'm just gonna do this in the debugger, I think, because break main, run, next, iterator, print. See, that's it's just the default constructor. Bang, yeah, so nonsense. But definitely now we should you not while iter next. Yeah, so now we do from here next, and that should continue iterating until it's legal. So it should return a legal position. So we're going to increment the rook, and then the kings remain on top of each other, so that won't help much. That should just finish. Oh, no. Well, actually, no, that was not what I wanted. How do you do that? Um, Oh, it says 0. Ha. That should be a 1. There. So yeah, now I put the king in the right position. So with black to move, the very first position is this position. And then black just moves out of the check. So the second argument is 0, and then yeah, the king is a 2, of course. So 0, 0, 2, 0, 1, 0. Let's make this the initial position. BK something. Why does it say white here? I thought it should have been black. So some position, comma, the black king, of course. Position, comma, the white king. And then here again, some position. The position being 0, 0. And the white king is at 2, 0. And 1, 0. Yay. And it continues correctly, yeah. A bit too slow now. So as soon as white is to play, then the rook should not start here. And the rook should... Oh, wait a minute. It is okay if black is a check, if they can take the rook. The rook here is a legal position. You can just take the rook. I have to change that. But yeah, let's test if the next one is to play. I don't want to wait till it goes to the end. At least let's just make it faster, I guess. 10 times fast. Can I still see that? So if the rook comes here, then it starts over, but then with white to play. And then we have to check that it does not start here. I couldn't see that, but it does not use this column, so that seems to work. But yeah, I'm pretty sure it also skipped that point, so that's not correct. Oh, it's even more complex. So it's not okay that the rook is here, but it is okay that the rook is here, because in this case the king can just take the rook. In this case the king cannot take the rook because the rook is protected by the white king. Holy... Seriously, that's a really big check, man. Yeah, got to do it. I'm so not going to take into account castling moves for the white king and the white rook. Just kidding. So 3 is way more complex. White is to move. Black king and the white rook are on the same row, and the white king is not in between them. That would be illegal, except when the black king and the white rook are next to each other and the white rook is not protected. I think the easiest thing would be to just already have available the distance between the rook and the king. Both kings. So the distance, well, if the distance is 1 anyway, but might as well use the distance. and that only, well, yeah, where one of them is 0, otherwise I don't even care, so I can basically add the distance. Something like this, but then, okay, so we have a dx to the black king, so the black king dx, a lot of dirty. That's not even dx, man. I want to know the distance. Distance to the black king. So there's a distance between the rook and the black king. Okay, the black king is on the same row as the white rook. White is to move, we already checked it. And the black king and the white rook are on the same row. That would be this. Stop popping a white up. And the white king is not in between them. That would be tested by this. Nor, that's basically the same as and, I guess. And the black king and the white rook. Nor are the black king and the white rook next to each other, while the white rook is not protected by the white king. So illegal means that the white king is not in between them. And it is not the case that, so again a not, I guess. It's not the case that the distance between the white rook and the black king equals 1. While the distance between the white rook and the white king is also 1. Wait a minute, that's not correct. I mean, the not here means that that makes it a legal position. So legal means that the black king and the rook are next to each other and we can take it. So this must be a not equal to 1. And then here we get the same thing. That's a better way, right? I mean, I never have it. It just wait for key. Yeah, I have the feeling I have that somewhere, maybe in utils. I so seldom use that. What? How do you do that? Pretty sure I have that somewhere. I just don't know. I would say wait. Or something with press. Nothing. Strange. Where's my Stack Overflow? Totally happy with that one. I don't think I have an end line here yet. Does this flush you out? Hopefully. No mercy in. Shocking. That's the first legal move, yes. And yes, so it skipped this one because then the rook is protected. No, it's nonsense. It should not have. It's this one. I'm a complete idiot again. Sorry. Black to play. So yeah, we just get everything. But okay. Brilliant. So it goes from here to there. Then now the rook here has been skipped because you can't take it then. And white is to move. No. But this one isn't because black just can take the rook. Yeah, that works. And then next is there. Yes, that's stalemate. No, it's not because white is to move. And then we go there because here is not allowed with white to move. Then it just can take the king. Yeah, so that works. Awesome. And then if you reach the end, the white king must of course skip again. Now the white king would normally move here, but we have to skip that because then the kings are next to each other. Yep, and now this is black to play. So black just takes the rook. Black to play. That's again totally okay. Yep, very good. Totally works. Oh, I've been a complete idiot again. This is not okay. What? I'm such an idiot. Never mind. I'm not even going to explain how much an idiot I am because I'm ashamed. But this is not a legal position. Nope. White to play. This cannot be in check, period. What was I thinking? Where's my board editor? Yeah. Yeah, I should go to bed. I mean, in as if I believe that it is a lack of sleep. My brain is just rotting. The stupidity of it all. White is to move, white is to move, and the black king and the white are on the same row, and the white king is not in between them. Period. Doesn't matter that you can take the rook. It's not his move. Arg. Yes, I am. I'm a naughty boy. I'm a naughty boy. Sorry, Poet Bunny. In chess. Yeah, well, I guess it just works, doesn't it? Now, why am I testing with 16 by 16? Because it just takes very long. I could might as well do this test with 8 by 8. But I believe it. Okay. The legal positions have been checked. So what was next then? Before I go to bed, I have to realize what the next thing is. Next is I detect all the positions that are made. Already made. We also have stalemate. I guess I have to remember those positions as well. Might as well call them illegal, as it were. Well, nah, not really illegal. But white wants to avoid them almost as much as an illegal position. You know, some positions are just stalemate. So if the very first position is stalemate, then it is stalemate. Otherwise, white will win. Yep, so I want to have a container with all positions sorted by the distance to the corner thingy, and then for each of those positions want to know which are made, which are stalemate, and the rest just go into container as they are. So it's made, stalemate, or none of those two. Yeah. So it's 3 possible things. Okay, I go to bed. Good night, Post. Yeah, always aims. Oh, can I go to bed without playing game of chess first? You have earned a yearling badge. Oh, that's. Oh, I asked this question. Someone answered it. I asked this question. How is this apparently losing position? I draw. In this position, white, me, gave up. Cry. But apparently it's a dead draw. What is white's plan to draw? Surely it's not obvious, is it? And we have an answer. How many answers? Just one answer. The key is to know that king plus rook versus king plus rook plus f plus h, holy shit, is a theoretical draw, provided the weaker side's king is close enough to the pawns. So white must keep the rooks on and get the king a bit nearer the pawns. That's a bit vague, isn't it? This is a theoretical, if difficult, draw. Well, I wanted that to be explained then, you know, like, so I can keep it a draw against the computer. The plan here is to move the rook to a1 or a8, to there or there. depending on what black does, and then harass the pawns from behind or in front. Very unclear. If black ever allows the white to win the f-pawn, then it becomes an easy draw. And if the h-pawn, then a standard book draw. Yeah, well, okay, if you say so. It's not super clear to me. It's not clear at all, actually. I mean, the computer already told me that it is a draw, but why? Maybe I should not have done that. Oh. It's a bit weird about my backward spawn on open file, but at least it's no longer on an open file now. This one has become pretty damn bad. Let's exchange the other one. Wait, he's just taking there then. I can't do that. I can do this though. Okay, I'll stay here. A rook here. I don't like that. Can I? But I can't castle. I have to do something like this, and I lose this pawn. Why? Why is it so bad? Is it that bad? I give this square to the bad bishop. But he doesn't take it. Now I can do this. Because, well, at least this pawn is not going to be taken anymore. Probably should just move this pawn up. Or maybe move this pawn up. Block that one. It's kind of weak. Could put my bishop there and there. And the king here, queen here. And then attack that thing. Is that very far-fetched? Let's just do it. Yeah. Wait a minute, I'm blocking my queen then. No, let's move this one. Oh, I'm threatening to castle. Oh, he wants a, definitely wants a rook here. That just one stoke there. He's insisting on having the rook there. If I castle and the rook comes here, I can't even move my queen here because then my bishop is hanging. I can move the bishop over there. And then maybe he takes my pawn. I have to castle. Period. We just have to do it. Maybe you should not have done that. I mean, a pawn is a pawn, and then that pawn falls as well. Eventually. Yeah. Really? I want to go there, but I can't get there. I'll have to play this pawn maybe. Way too slow. Yeah. Gonna promote that thing eventually. I don't think so, but that is. Oh, I gave away my queen. Yeah. Oops. Shall we resign or shall I just continue playing? Because otherwise I have to go to bed. I don't want that. I think resigning is a very good option here. Yes! I got a cellmate. Ha ha ha, evil laughter. No, I'm going to bed. I got a dream of this still mate, like hours and hours. And then, put clean sheets on it tomorrow. I mean, yeah.